Hello and welcome back to Curtitus Math. So today we're going to be looking at the Pythagorean Theorem level 2. So this is just the Pythagorean Theorem, but with some more complex examples. So I call it level 2. Just a little refresher, our main formula that we use for the Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the legs of a right angled triangle and c is the hypotenuse. So here if we have our little right angle, the side that the right angle is looking at, so right across from it, that's always our side C, and the other two sides are labeled A or B interchangeably. It doesn't really matter if you label this one A or B or this one A or B. The only thing that matters is that the longest side is labeled as C. Okay, so knowing that that is our formula that we're working with, we're going to get right into it. So question number 1 is asking, what is the measure of AC? So AC, that is this side right over here. So when we're doing Pythagorean theorem questions, we really want to kind of unpack the shape that we're working with and locate that right angle triangle right away. So if we're looking for side AC, we can either use the triangle that's over here, or we can use the triangle that's up over here. It doesn't really matter. I should specify that the shape is a square. So that is something that the question did state. I just cropped it out. So A, B, C, D is a square. So that's something that we know. So we can use either the blue triangle or the green triangle. They are the same triangle. They're identical. They're just kind of in the reverse order. Or I should say the reverse orientation. So I'm just going to use the green triangle. And I'm going to label everything that I know. So since I know that this is a square and all squares have the same side, same measure on each side, that means AB is also 10. So the most important thing to do when doing the Pythagorean theorem is to label. So step 1 is always label your sides. We start by labeling C. So since our right angle is over here and the right angle is looking at side AC, AC is our C. Now the other two sides are labeled A or B, it doesn't really matter. But we're going to use our formula, pop it right in here. This I'll push off to the side, and it would be useful if we gave it a nice little box. There we go. So step 1 was label, step 2 is write the formula, step 3 is plug in everything you know. We know A, we know B. So we're going to plug in 10 here, 10 here, and solve. So 100 plus 100 equals C squared. 200 equals C squared. And I should have had my calculator prepared here. The square root of 200, that's 14.14. So to undo that square on C, we need to square root on both sides. And we get 14.14 units, or centimeters. Actually, we know that they are centimeters, equals C. That's the answer for number 1. For question number 2, this one's a bit of a more interesting problem. Determine if the triangle below is a right angle triangle. So this is kind of more of like a proof style question. It's more of a pure math question. So prove or determine, is this a right angle triangle? So what do we know about right angle triangles? We know that if triangle ABC is right angled, right? If this is true, then A squared plus B squared would equal C squared. That would be the statement. If this was a right angle triangle, then this statement will be true. So we do the same thing. We label the longest side here, since we don't have a right angle to kind of use as our guide. to label our sides. We're just going to label C as the longest side since we do have the measurements of all three sides. So we're going to label this as C, and the other ones we'll label as A and B. So plugging everything into our formula, 5 squared plus 6 squared equals 8 squared. And now we just do those calculations. So we get 25 plus 36 equals 64. Now we add 25 to 36 and we get 61. This is not true. So either you can do a true math way and do a little lightning bolt and say contradiction, which is the kind of the funnest part of math proofs. Or you can just say false, error, whatever. And then you put you can put 3 dots that mean therefore. You can say so triangle ABC is not a right triangle. So this is our reasoning. It's really kind of like an argument, right? So we're saying if this is a right angle, then this would be true. We check, we find that it's not true. We say false, so that means this is not a right angle triangle. Okay, question number 3. Find the area of the triangles. So these are more multi-step problems, since there is some information missing. And we also need to do additional steps. It's not just straight Pythagoras. There is a little bit more work to be done. So for this, we're going to do a little reminder. Ooh, what happened there? Okay. A little reminder. The area of a triangle, that would be base times height divided by 2. So that's a reminder. And actually, looking at this now, I think I'm definitely going to need more space. I'm just going to move all this stuff down. Sorry about that. Okay, there we go. More spacious. So again, we want to kind of unpack what we have and where are my thoughts? Yeah, unpack the right angle triangle from the image that we're being given. So here we have this right angle triangle, so I'm going to highlight that. Okay, so that's our right angle triangle. We're going to label all our sides. So our right angle is right up over here, which means looking over from the right angle, that's going to be our side C. And then the other 2 sides of this triangle are A or B. Okay, so that's one piece of information that we have. Another thing that we should notice is that these are both 11s, which means that this is an isosceles triangle. And if this is isosceles, then this kind of dotted line here is cutting this triangle directly in half. So if this side is 7, that means this side over here must also be 7. That's another piece of information that we can put in. So in order to find our area of a triangle, we will need to be doing base times height. For now, we have our base, we have our 2 halves, so our entire base is 14. We need our height. So that's where we're going to be using Pythagoras to find our height. So that's step 1. We're going to put in our formula, a squared plus b squared equals c squared. Standard. Plug in what we know. A is what we're looking for, so we're going to leave A just as it is. B is 7. C is 11. So we've got 49 equals 121. And now we need to solve for this A. So we're going to subtract by 49 on each side to isolate that A squared. 121 minus 49. we have 72. That's a squared. We don't want a squared, we want just a. So we need to undo that square by square rooting. And that's going to give us just about 8.5. So we're going to say 8.5. Now we have the height of this triangle. We can finally find the area. So now we would use our second formula. Area of a triangle is base times height divided by 2. Same thing, we're always writing out our formula, plugging in what we know. So now our base, that would be this whole thing over here, 7 plus 7, that's 14. So 14 times the 8.5 dividing by 2. So really writing everything in. 14 times 8.5, 119 divided by 2 is 59.5. And I guess the units were not written, so units squared. And that would be our final answer. Okay, so these are multi-step problems. Okay, B, same question, find the area. Oh no. Okay, I have to do this a little faster. Okay, so finding the area of the triangle, of the entire triangle. So here, area of a triangle, base times height divided by 2. So looking at this triangle, we do have the height. So height is not a problem, we've got that. What we need is the base. So this right over here. You might be tempted to use this entire triangle to find this, but you're not being told that this over here is a right angle. You don't know that for sure. The only thing that you know is that this line creates a right angle here. So you can't assume that this is a right angle and use Pythagoras here. You need to actually break this up into two separate triangles in order to find that the base of the full one. So we're going to need to do Pythagoras over here, and we're going to need to do Pythagoras over here. So we've got two mini triangles to work with. So I would recommend kind of breaking this up into two little sub-problems, drawing your two separate triangles. So here this is the first, the 15 and 16, and do your standard steps. So step 1 is always label your triangle, look for your right angle, look across from it, that's your C, and then label the other sides as you wish. Step 2, write your formula out. Step 3, plug in what you know. B is 6 and the B's already kind of look like 6's. Okay. And step 3 is solve for what you don't know. 15 squared, that's 225. We want to get a squared, so we're subtracting 36 from both sides. Left with 189. And now we square root. And we get 13.75. Okay, so that's this first piece, 13.75. Now we need to do the little pink triangle. So that's what I'm going to do over here. So this we know is 6, 7, and we're missing that side. So same exact steps. We look at our right angle to guide us over to our side C, label our triangle, write out the formula, plug in what we know, and solve for what we don't know. So those steps are always the same. 49 minus 36, that gives us 13. Square root of 13, 3.6. So now this side right here, that's 3.6. And now we have the base of our triangle. So 3.6 plus 13.75. This entire base of this whole triangle is 17.35. So base equals 17.35, and now we can solve for the area. Times the height is 6, and divide by 2. $52.02. Okay. So I am actually going to skip this C question since I'm running out of battery, and I would like to do this example. Okay, so in each of these right triangles, the median AC is shown. So this is a word that I did want to go over. So what the word median means, if you don't remember maybe from last year, or maybe we didn't get to it because of COVID. So what the median is it goes from kind of the corner here, and it's this little dotted line that connects the corner from to the side that's across from it, and it connects it in the middle. So that's what a median is. What it's doing is it's cutting this side into equal pieces. So this means that BC and CD are the same size. That's what you need to know from median, from the word median. Okay, so now it's asking, calculate the difference between segments AD and AC. So it wants the difference between AD and AC. So those are the two sides that we need. Okay, and remembering that we always need to unpack our right angle triangles. No other triangles are useful to us, only the ones with right angles, since those are the only triangles that we can use Pythagoras with. So the first step is dealing with this median thing. So because we know that these two pieces are the same size, that means that each one is this 29 cut in half. So we're going to take 29 and divide it by 2. So that means that this here is 14.5. And then the orange part is also 14.5. Okay, so that's the median business. And now we can pull out the two triangles that are going to be useful to us. So what I like to do is kind of focus on this right angle. So I'm going to kind of look at where the right angle is. So one side from the right angle is here. Then the other side I'm interested in is this AC. And now to create a triangle with those two is to do this. So that's one triangle dealt with. So I'm going to pull that triangle out. Oopsie, what am I doing here? There we go. So we've got A, B, C. This is 10, our right angle is here, this is 14.5. And this is one of the sides that we care about. Okay. So now again, focusing on that right angle. This 10 is the only side we have on this kind of left side of the shape. So I'm for sure going to need to highlight this side again. And now the other side that I'm interested in is this AD. So I'm going to highlight AD as well. And now to make a triangle with this, I need to use this full side. So this is my other triangle. I don't know why I made a rectangle there. So now we've got A, B, D. And this is the other side we care about. Okay, so when I was making my triangles, you see how I focused? I started in order to figure out which triangles I needed to unpack from the shape. I focused on the right angle. I started here. I did not start with what I don't know. You start from the right angle, you build outwards from it until you reach the sides that you're looking for. Because if you were to do it in the reverse order, you might decide to look at this triangle, but this triangle here does not have a right angle, which means it's not useful to you in terms of Pythagoras. You can't do anything with this triangle. So that's why it's better to kind of focus your attention on the right angle and aim outwards towards those sides that you're interested in finding. And that's going to help you locate the right angle triangle that will enable you to solve the problem. Okay, so now it's just standard Pythagoras on the two triangles that we've unpacked. So same process. Step one is always label. So on this little triangle, looking at my right angle, I look across, that's my side C. So C, the other sides are A and B, whichever way you want. Same thing with this triangle, this little right angle, look across from it, that's your C. And same thing over here, A and B. So I'm going to very quickly do this. So we put in our formula, we plug in everything we have, and we solve for what we don't know. The little triangle is 20.25 for side AC, and I'm going to do the exact same process for the big triangle. I'm racing against the clock here. I see I have like 2% battery left. Ooh. Okay. 841, so 941, and we're going to square root this. Square root of 941 is 30.68 is C. And going back to the main question is calculate the difference between the segments. So we want the difference between them. So we need to subtract big minus small, 30.68 minus 20.25. So the difference is about 10.43. Okay, and that about wraps up our Pythagoras video for level 2 Pythagoras, more complex questions. Okay, I hope that this was helpful, and I will see you in the next one. Bye-bye.